All right, let's take a look at Nancy Pye's work. All right, and what she brought us towards. And so she had two answers. The first one was x squared plus 3x. This is the problem that she led us through, plus 5. Right? And then it was divided by x plus 1. And she found the answer was x plus 2. And there was a remainder of 3. All right, and then she wrote her answer, right, incorporating the fraction over here. But the statement still here is in the form of a division statement. And so what we're going to do is write it in a multiplication, in a multiplication form. And so we would say that x squared plus 3x plus 5, right, that's our dividend, is equal to x plus 1, that's our divisor. Our quotient was x plus 2, and then plus the remainder. Right, so this is the remainder, and we just add it to the multiplication of the divisor and the quotient. Or we could write it as x plus 1 times x plus 2 plus 3 divided by the divisor. And so you can probably see how these are exactly the same here, right? We've got x plus 1 times x plus 2, right? Those two quantities would multiply by each other. And then just sort of thinking of this as distribution, right? X plus 1 times 3 over x plus 1 gives us that 3. So these are equivalent. These two forms are equivalent to each other. These are the two multiplication forms. All right, and in Nancy's problem number 2, so just to remind us, so she had a little bit more complicated expression. There was no x term, right? And then it divided by the quantity 2x squared plus 1. So again, a binomial, but one that is a quadratic or a second order. And she found the answer to be 3x plus 5. That was the quotient. And then with a remainder of minus 3x plus 3. So it was not a constant, but right, a linear function. And so in multiplication form, right, 6x cubed plus 10x squared plus 8 is equal to what we found it to be equal to. There's the divisor, right? Here's the quotient. And so we're going to multiply those together, and we're just going to add the remainder. And I'm going to just use parentheses so that it's easy to see. You don't have to obviously have those in, but there's the remainder. Right? Or we could write it as, there's the divisor, times 3x plus 5 plus minus 3x plus 3 divided by 2x squared plus 1. So this again would be equivalent. You can sort of see that by distribution, right? You think of this term distributing there and there. So we've got that going on down here as well. And then this remainder shows up, right, once we distribute the divisor, right? Then the numerator and the denominator cancel, and then there's the remainder. So this would be in the two multiplication forms.